This video is about speech processing in SSB mode. I will use this IC706 MKIIG to transmit on 14 MHz. Firstly, according to the instruction book, and then with the Linrad speech processor. This thing connected between the microphone and the transmit input. And I will look at the resulting signal with another computer running Linrad as a receiver with a Perseus hardware. So I can start by, where is it? Oh, here is it, by clicking the microphone and talking into it. And you can hear there is a considerable time delay. I didn't bother about finding good sound cards for this computer because the delay is of no significance in this experiment. The signal I can see, here I can see the spectrum. If I say ah or something else, you can see there are, well, just talking normally, you can see the width of the signal. I don't have the storage on. This is just the first having a look at it. The S-meter shows with the white track the peak power, and the yellow is RMS power. So 1, 2, 3, 4, 5. You can see the peak power and the RMS power not so high. I can then press the compressor and now run this transmitter with the speech processing on. 1, 2, 3, 4, 5. And you can see now the peak power is at about 1 dB on this scale, while the RMS power is at about -4. So there is a 5 dB difference only between peak power and RMS power. That's pretty good. There is a considerable compression in this radio. Looking at the spectrum, it doesn't look much different. But it's easier to get feedback into the microphone from the loudspeaker because the gain is now much higher. So this is the barefoot IC706, and I will now check the frequency response because I need to know that. I'm using this signal generator to send a signal into the IC706, and then I look at the S-meter here. While changing the frequency. So this is a typical crystal filter with some ripple on it. Not much, but about 2 dB, plus minus 1 dB. The upper 3 dB point, you can see the peak power is increasing because the microphone is in parallel and it's not too far away, so my voice goes into it a little bit. This is 2.7 kilohertz, and the lower frequency It's a little bit uncertain what I should say is the lower frequency, because the curve isn't so distinct here. But this is 360 Hertz, or maybe I should put it a little bit higher. No, 350 Hertz to 2.7 kilohertz. That's the frequency range we want. As I've shown in a previous video, I found these parameters good for my own voice. With a microphone I have connected to this computer. So it's from 190 Hertz to 2.5 kilohertz. That is about 200 Hertz lower than what the IC706 wants. So I press P, and here there is a possibility to use E and add a frequency shift of 200 Hertz. Means from 400 to 2700 Hertz instead. This should fit the 706 quite well. This is the mode for modest compression. You can see there is very little RF clipping, only on the strongest peaks. And the ALC is working a little, but not very much. If we look at the power on the S meter, 1, 2, 3, 4, 5, 6, 7, 8. It shows a fairly large crest factor. The peak power reaches often the maximum level, but the RMS power is not so high. Looking at the IC706, you can see there is almost no ALC action. Very little and just occasionally. Looking at the spectrum, I think one can see that it is considerably narrower than it was before. This will be more clearly shown later when I will use the mode for TX testing where there is a peak hold function. I have now set the DX mode, which was in the previous video saved as SpeechProcessor01, and I have added a frequency shift of 150 Hertz. When I talk into the microphone like this, you can see on the IC706 there is no ALC action at all. On the S meter here, 1, 2, 3, 4, 5. You can see that the compression is quite good. And looking at the spectrum, it is a little bit narrower than it was before with the speech processor of the IC706. In the year 2003, I made measurements on the IC706 at a meeting in the southern part of Sweden. I hope you can see the link here. It is rs03.htm. And the station was owned by SM7XXA, and I click here, and here you can see the spectrum. with Linrad in TX test mode. This is with the WSE converters, and the total span is 96 kHz. And here is the mirror image, because this is a direct converting system. The green curve is the peak hold spectrum. The red is the RMS, and the white is RMS but in a narrower bandwidth. Here is the same, but now the radio is the Perseus. The bandwidth is also 96 kHz, and I can speak into the microphone. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see here how the level is on the ALC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I shout really loud, "Ah!", you can see that's the limit I should never reach. So you can see when I went outside the limit, the green curve went up. I caused splatter on the band. And the manual says, while transmitting at your normal voice level, the ALC meter should read at about the middle of the ALC zone. Be sure the mic gain is in the range 2 to 5. So the mic is here at 5, and I will clear the peak and hold, thus pressing Z. And now speak into the microphone and try to not go over the mid-range of the ALC. 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. 1, 2, 3. Up, down, middle. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And here is the peak hold spectrum. This is very similar to this result from 12 years ago. So again, here is the transmitter test mode of Linrad, and I'm running the 706 as recommended by the instruction manual. And it may help, if I look for splatter, to leave little gaps between syllables like this, because there is something with the ALC that causes splatter on this rig. This is now without the compressor. I will switch in the compressor and see if there is a significant difference. You can see the mouse cross is at 130 decibels. That is the peak power that we have now. And I clear the spectrum and then talk with the speech compressor enabled. And there isn't much difference, one can see here on the peak levels of the splatter. Note that 20 kilohertz away we are at about 70 on the scale, and at 100 and at the center frequency we are at 130. So that is 60 decibels. 60 decibels suppression of the splatter. The measurement bandwidth here is 2.4 kilohertz. So it is the bandwidth our friends are going to listen to our splatter in. And this is a bit wider than we like. It's not the non-linearities of the amplifier that cause this, it's the ALC. I have now switched to CW mode and pressed the key. And this doesn't look so bad. There is some peculiarity down here that shouldn't be there. But now I'm running at full power. You can see H. I turn the power down. Let's say 4. Then look at the spectrum here while keying. And you can see this looks ugly. Something is oscillating and generating sidebands symmetrically around the carrier. I can press F4 to get into the time function. So I send some dots here. And then P to make a pause. And then I to increase the time for each dot. And then the arrow. And then D to decrease. And then the arrow. And decrease again. And here is the first key down. It may be easier to see if I press W to make lines instead. You can see the ALC acting and then the oscillation starting. If I look for the next key down, here, the red is the frequency, which is undetermined when the key is up. Then you can see the next key down is much better. There is an oscillation, but not as strong, because at this short time after key up, there is still some ALC voltage. So that's how it works, and it is active in SSB mode also. I'm now running at reduced power. I set it to 4 in SSB mode. And look at the spectrum here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dot, dot, dot. And we know there is a memory effect, so I have to talk with empty space between syllables to actually get the worst malfunction from the ALC. And if I talk steadily, you can still see something pops up now and then at large distances from the center frequency. So the oscillations are here in SSB mode also. Don't use this rig at reduced power, particularly not if you have a power amplifier after it. Use an attenuator of some kind and run it at full power. Or insert a speech processor in front of the radio. Note that the power is about 126 or so, that is 4 decibels, maybe 5 decibels below the full power. So we are in the order of 30 watts if 100 is the full power, if I recall properly. And you can see from the spectrum that we have these oscillations, that is the dominating splatter, and that's is it 5 kilohertz away or something. And they are suppressed by only 15 or 17 decibels. That's not much. I'm now using the Linrad speech processor and talking into the microphone for full power. And I have set the level to 5 dB below the maximum power of the radio. That's the level I showed before, 125 or maybe 126 on the scale. And you can see proper speech processing to reduce the power rather than using the ALC circuitry, gives a much cleaner spectrum. And the compression is probably a little bit higher, so I think the copyability, at least at low signal levels, is a little bit better running like this. I can increase the power a little bit. I have brought up the level by 2 decibels, and you can see it didn't go up quite as much as 2 decibels, more like 1 dB, but I cannot see any bad effects yet. And now the level is 2 more decibels up, and we are close to the 130 on the scale where the ALC of the IC706 acts. And we can see there is some broadening of the signal. And we can see this is the RF power. I have to look at the ALC, and there is no ALC at all on the meter, but the ALC is active, as we can see on the spectrum. Now I increase the level to more decibels, and we have severe splatter relatively, and full power. So the ALC starts to act long before it shows anything on the panel of the IC706. I have now selected the aggressive speech processing in Linrad for DX on weak signals, and you can see that the RMS power, the red, is very close to the peak power. It is usually about 7 decibels or something like that. The power is now 125, so we are 5 dB below the maximum power of this radio. And I go up in steps of 2 decibels. So now the signal is 2 decibels stronger into the microphone of the IC706, and it didn't increase by that amount. 2 more decibels, and well, maybe, but we can also see ALC action. The signal is much wider. So this is too high for a clean spectrum. I go back, let's say, 3 decibels from here. To call this a good compromise for using Linrad as a preprocessor to the IC706. And just to remember, I will now go back to the original microphone at full power. So now this is the normal operation of the IC706, and maybe I was speaking a little bit too hard into the microphone. Let's make it like this instead, to make sure the ALC indicator doesn't go too high. It still looks like this, and the ALC shows like that. So it's clear that a speech processor in front of the radio is a good thing. I'm now running the IC706 with its own microphone and with the compressor. And you can see, if I talk slowly, 1, 2, 3, 4, 5, 6, 7, 8. That the peak power is at plus 1.5, and the RMS at minus 4.5, roughly. I will now switch to the Linrad pre-processing. The power is set to 3 decibels below maximum. That's just below the point where the ALC starts to widen the spectrum. I have to go these 3 dB down, probably mostly because that the filter, the crystal filter, is not perfectly flat. And if I talk slowly, 1, 2, 3, 4, 5, 6, 7, 8, you can see the peak power at minus 3 dB or so, and the RMS power at, I've forgotten, 1, 2, 3. Minus 4.5 or so. I have now introduced 100 dB of attenuation, and now I'm talking through the Linrad speech processor, and I press S and make a recording. I call it just test, and now let's say Alpha, Bravo, Charlie, Delta, Echo, Zulu, and well, a little bit of speaking, because I will play this back, adding noise to the signal to bring it down to the level where it is difficult to copy. And then I will do the same with the signal generated by the IC706 without the speech processor in front of it. So I make this switch now. Now I'm talking in the ordinary microphone of the IC706. And you can see that the peak power and the RMS power is a little bit higher than it was with the speech processor. The frequency, if you look at the waterfall, the baseband waterfall, is a little bit different. The bandwidth is just a little bit wider. Particularly on the low frequency side. So it will be interesting to listen to this with some noise added. So I make a text file, adfile.txt, and then I put the name of the saved file in here. Now I can press 1 to process the first file named in AD file. And I want to run it in SSB mode, D, and repeat endlessly, yes. Press any key. I have to give parameters, and I just go for the standards, press enter. And here is the recording I just made. And wrong sideband.
To bring it down to the level where it is difficult to copy. And then I will do the same with the signal generated by the IC706 without the speech processor in front of it.
I don't remember myself. I have to go to the main menu and press F1. And here, add noise when F11 is in use. I wanted to add noise when playing a recording. Seems I have to add something here. I now made some little changes so I can add random noise while doing this processing. So, 1, and here is the recording, and I click on the signal.
Alpha, Bravo, Charlie, Delta, Echo,
And you can see on the S meter graph the peak power and the RMS power in yellow.
To the signal to bring it down to the level where it is difficult to copy. And then I will do the same with the signal generated by the IC706 without the speech processor in the
You can see in the waterfall here that the power is very evenly distributed over the frequency range.
Now I'm talking in the ordinary microphone.
And I have to switch the frequency of the BFO because the frequency is a little bit different. The frequency is not as evenly, the power vs frequency is different. The peak power is nearly 1 unit higher, but the RMS power varies more. It reaches a little bit higher levels, but it is often a little bit lower. So I will now switch over to do a screencast from the screen, and then my voice will disappear and you will just have to look at the screen when I play with the settings of Linrad with increasing noise levels on this recording. The noise is added by pressing F7. You can see. And now it's not so good anymore to record through the camera.
Talking in the ordinary microphone of the IC706, and you can see that the peak power and the RMS power is a little bit higher than it was with the speech processor. The frequency, if you look at the waterfall, the baseband waterfall, is a little bit different. The bandwidth is just a little bit wider, particularly on the low frequency side. So it will be interesting to listen to this with some noise added.
Now I have set the S meter to show S units and calibrated it for S0 when there is no signal. And you can hear, I guess, even through this camera, that there is no problem to copy the signal at S1. And it is regardless of whether I'm using the speech processor or the IC706 compressor. And it's very clearly visible that the peak power of the speech processor that we see now is much lower, but the RMS power does not differ very much between the two.